Hello guys, welcome back to algebra class again. So this time we are going to learn about exponential function and especially about graphing. So there is one concept that I want to teach you which we call horizontal asymptote. So let's get started. So this is what we are going to learn today. So as you know, 2 is going to be our base, right? With this exponent. And as you can see, we don't have any initial value here. That means there's hidden number 1 here. Okay, so it's 1 times 2, something like that. Now when you graph this one, no, not this. So let's graph it. When you graph this, you will see something interesting. Y equals 2 to the x power. So this is going to be the graph. Now, do you see something interesting? Let's keep going up and keep going down, but you're gonna see. Let's look at here. But you will see here. This. Look at the y value. You're gonna see this y value does not go below 0. Keep going down, isn't it? Just keep going down, but you will see it will never ever go below 0. So just keep going up here. It's going down, but as you can see, this y value does not go below 0. Now, then there's going to be the limit, which we call this line here, this x-axis. That's going to be the limitation line. We call it asymptote. Okay, so here, asymptote, let's write it here. Asymptote is an imaginary line that graph can get close to, but will never touch. So that's right. It's gonna be the graph like this. If you graph exponential function, the graph will look like this, something like that. It's keep going up and it's going down, but it will get really close to this line here, but it will never touch this line. Okay, that's what we call asymptote. So based on this one, we are going to find x-intercept, y-intercept, and the range. Okay, and of course you will learn how to find asymptote as well. So x-intercept is where this graph touches this x-axis, which means this where x is equal to 0 here. But let's look at this graph. If you click it, as you can see, you can find y-intercept easily, right? Which is 0, 1. But x-intercept, not really. Can you see any point here for the x-intercept in this x-axis? No, because as you can see, this line will get really close to x-axis, but it will never touch. It will never touch this x-axis. It will never touch here. Since this graph will never touch here, it will never cross this point like that. There's no x-intercept, so this does not exist. Okay. Then what is the asymptote? Horizontal asymptote, because it's a horizontal line. This is gonna be our asymptote in this graph. So what is this line called? What's another name of x-axis? Let me give you a hint. This line, we call it y equals -2. This line, we call it y equals -1. Then this line, we call it y equals 0. That's gonna be horizontal asymptote. This one is a y value, not x, because it's touching y-axis here. I mean y here, right? Y equals -3, -2, -1, 0, 1, 2. Like opposite wise, x equals 1, x equals 2, x equals 3, like that, okay? So let's talk about the range. Range is y values, all possible y values that this graph can get. So where does this graph start from? The bottom. This graph will get really close to this y equals to 0 because you're going to only use these numbers. It will get really close to 0, but it will never touch. So we start from the 0 here. You cannot put line underneath it because this graph will never touch 0 to the y. And what's the highest point that this graph can get? Because y is lowest point to the highest point. This graph will keep going up, so it will keep going up to positive infinity. And of course, we can only use this one because mathematicians are lazy. We don't want to write infinity. And also, we want to write variable first, so you have to flip it. So it's going to be y is greater than 0. This is going to be the range, okay? So now I want you to try this question. Oh, let's do it together. Let's try this question together, okay? So y equals 3 to the x, and we have plus 1 at the end, right? So let's look at this graph here. Now, do you see this graph here? It's keep going up here, and it's keep going down, but it does not go below 1. Then our asymptote is gonna be y equals 1 because it says it's touching 1, but it's not 1. It's getting close to 1, but it will never touch 1, okay? Do you see this? Look at the y value. X value changes, but y value stays 1. That's gonna be our asymptote. So this line, that's gonna be our asymptote, which is y equals 1, and then the graph continues like that, right? So let's look at x-intercept and y-intercept. Y-intercept is 0, 2 in this case. Pretty easy. But x-intercept, as you can see, this line, this graph, will never go below 1, which means it will never touch this line anyways. So x-intercept does not exist in this case, okay? Not always, just this case. Because if you can see in here, because of this -1, you will actually see x-intercept in that case, okay? Now let's talk about the range. Range is the lowest point to the highest point. Lowest point this graph can get is like this +1, right? Because it will get really close to, but it will never touch this 1. So we start from the 1, but we cannot include it. And it will keep going to the positive infinity. So this is going to be our range, which we have to flip. So y is greater than 1. All right? So I want you to try this question by yourself. Now you got to put, what's that called? Fraction. It's not going to be a problem, right? Try this question by yourself. Just let me put, just in case. Let me just show you how to put fraction. Just put 2 divided by 3 to the x plus 1, just like that, okay? That's all you need to do. So you can find y-intercept. You can, by clicking in, you can kind of find what asymptote is. It will never go below 1, as you can see. So it's gonna be 1, okay? Wait, what was the y-intercept? No. Okay, so you can just do it like that. So just label the asymptote, and this graph look like this, and then find range and x-intercept, okay? So let's try this question together. Last question. Now you see negative in front of it, but it's not gonna change anything. Not really, okay? And here we go. Just only thing that you have to do is this. Just put negative 0.125 to the x power minus 1. So we have this graph here. Our graph looks like this. It's pretty simple graph, right? Oops, this one doesn't have x-intercept, I think. Wait, does it? No, because -1 is gonna be asymptote, and graph looks like, okay, I made a mistake. But sometimes you will have x-intercept for sure, okay? I will show you an example later. But now we can see 0, -2 is gonna be our y-intercept. It does not exist because this -1 is gonna be our y-intercept, and our graph looks like this. This graph, as you can see, will get really close to this -1, but it will never touch. So that's gonna be our y equals -1. This is going to be our y-intercept. So what's the range gonna be if you have negative number? Obviously, the lowest point this graph can get is -infinity because it's keep going down. And highest point this graph can get is going to be -1. It will get really close to -1, but it will never touch. So it's going to be less than -1. Because it will never touch -1, you will not put line underneath it, okay? So here, we're going to only use it, and we don't have to flip y because y comes first already. So that's how you do. This is the graphing part of the exponential function. So we're done with this page. This one, I will record another video. You can watch that part, all right? So that's it, guys. If you have any question, just let me... Oh, wait, before I finish this, let me show you one case that you will have exponential equation. Let's say you have like y equals 2 to the x power, let's say -5. Now, do you see you have y-intercept and x-intercept here like that? So, in these examples that I showed you, you did not have any x-intercept. It was all does not exist. But just like this, as you can see, you can sometimes have x-intercept. So keep that in mind, all right? All right, that's it, guys. See ya.